Welcome to today's webinar. My name is Jihoon Kang, and I'm a technical engineer from MIDAS IT. So today, today's topic is application training, modeling and moving load analysis of pre-stressed concrete girder bridge. So I'll use the same model which we had a webinar last week. So we had a speaker who is engineer Chong Wee Lin from Malaysia. I'll use his model and show you how to build up a similar model. So these are the contents for today. So firstly, I'll show you how to use the wizard and time-dependent material and moving load analysis and automatic load combination. Then I'll show you analysis wizard. So we have this step-by-step procedure tutorial. This will be uploaded to our website. So today you can just follow the steps using this presentation file afterward. So today I'll more focus on this widget and this moving load analysis, and then about the widget, as much as we have time, I will explain detail about the analysis widget as well. So let's get started. So I'll start with the widget. I'll show you how the widget generates the model, and then compare the input value with the output, so you can understand how you will build up the model for your project. So just like this tutorial says, I will open up the model using MIDAS Civil. I'm not gonna start from scratch. I have defined material and section before using the wizard. So in this model file, you can, if you go to this tree menu and works tab, you can see what things are saved in this model file. So we have 3 material and 5 different sections and some tandem properties. So this is the composite section, which is for Girder, and this is another Girder section having a little bit different shape, and this end diaphragm is for crossbeam, and the number 1 section is for the pier, and this pier head is for headstock on top of the pier, on top of the girder. So if you have 3 materials and section for the girder, that means you are ready to use the wizard function. The wizard functions are on the structure menu here. We have various wizards here, such as a suspension bridge, cable state, and so on. But today we will use this pre-stressed composite bridge widget. Sorry. So we have lots of inputs in the widget. So I'm gonna explain to you how we can understand these values. And I'm not gonna input all the things right now. I already saved the wizard file. So these input values are not saved in the model file, but saved as this WGD file. So if you modify something or you start using the wizard, and if you want to save this input values, and if you want to use it again afterward, then you can save it as WGD file. So as I already input everything here, on the layout tab and section and tendon and so on, I'll click OK button. So before the wizard, we had only the material and section and some of tendon property, but now the wizard generated more material, more section, and there's more functions, and this boundary condition. You can display or undisplay everything using this works tab. And we have loadings and the pre-stressing and the tendon profile and so on. So I'll show you the comparison, the input value with the model. So I'll make a screenshot of this widget. So here we have input two spans having 30.1 meters each. So let's check this with the model. So if you want to measure the distance between the nodes, you can go to query menu, and we have query node, and I'll turn off this hidden mode. If you click once here and then click two nodes, and here message window says the distance between two nodes like this. So I clicked number one node and then number two node, and then this is the distance between node number one and two, and it says also along each direction, each axis as well. So it is 60.2, which is 30.1 times 2. So the wizard did correctly about the span information. And we will check also the stack width, which is 12.4 meters. We can also check stack width just clicking two nodes here. So it is 12.4 meters. And we have here spacing A, which is the distance spacing between the girders, and we have spacing B, which is spacing the distance between the bearing and the edge of the girder. This is spacing B. We will measure this. Spacing A is 0.2 meters, and spacing B is 0.3 meters. Let's check this out. If you use this active function, you can activate only the girder section. Using the control key, I'll select all the girder elements and then click active function. And I'll turn up the hidden to see the girder. So these are the girders, and I'll active plus the slab. Then you see I didn't check on this continuous girder. So it is not continuous. Girder is not continuous, but the slab is continuous. And the spacing between the girder is 0.2 meters along the x-axis. And for the bearing, this elastic links are representing the bearings, and I can measure from this bearing to the edge of the girder, and it is 0.3 meter along x-axis. Okay, and we have also different modeling type in the wizard. We can use different option rather than all frame. I'll show you this as well. So if you want to modify something the input value from the wizard, you cannot just open the wizard again and modify something and execute again. Then the wizard will overlap every data again. So it is just to update the model. It cannot modify the model. Please notice this. So if you want to execute the wizard again after modifying the input value, you need to undo the wizard and then implement the wizard again. So if we click on deck as plate and Girder as frame, for instance, here you can see slab is the plate element, and the Girder is beam element, and it is must be having link between the Girder and the slab. Sorry, Girder and the slabs are sharing the node, and this is to representing the Girder section to the bottom of the Girder section. Okay, but today I'll use all frame function, which is the simplest model. So we have done with this general information. Sorry, this general information about the bridge. If you want to make it as curved bridge, you can input this radius, and then we move on to this boundary and substructure. As we selected with substructure, it generated this pier and column and hashtag. So if I selected on this without substructure, it will generate only the girders. And here you can see bearing type, elastic link stiffness. So as I mentioned before, elastic links are representing the bearing. And then here you can input the stiffness of the bearing at the abutment at the pier. And here we have lots of values here. So here kx, y, z means from the model, our displayed elastic link. So you can see this local axis of the elastic link. So kx is vertical direction. I'll zoom in this. So k-axis is vertical direction, and ky is the transverse direction of the Girder, and kz is representing longitudinal direction of the Girder. So as we input 0 for kz at the abutment, so at the abutment longitudinal direction, the bearing has zero stiffness. How we can check these values? We can go to tables menu. You can click right button at the elastic link and go to tables. And here you can check all the values. And also here are some numbers. These numbers are representing elastic link numbers. If you go to this display option, display menu, and go to boundary, and you can display elastic link number. The number shows very small, and you can actually change the size of the font. Anyway, so this is number 1 elastic link, this is number 2 elastic link, and this is number 3, and this is number 4, and so on. So these elastic links should be having 0 value for the kz. So if you go to number 1 to number 4 elastic link SDZ, which is this kz, is showing 0 value. Here you can see it's 0. Yes. Okay. I'll close this table and move on to next. And also we have elastic link length, which is representing the height of the bearing. It is 0.125 meters. I can measure this in the same way using coordinates. This I frequently use this shortcut key, which is F4 key on the keyboard. Anyway, I'll measure this, and this is showing 0.125 meters. Okay, and here's the option for the pier. Here we have assigned number 1 material to the column and the headstock, and we have assigned for the pier cap, we have assigned number 6 section and input 12.4 meters. And here we have column. We have assigned number 1 section to the column, and the height of the column is 5 meters. And we have 7 meters as spacing, so we will have 2 columns. If you input multiple spacing, we will have more columns in the transverse direction. So we will check this out together as well. So to check out the substructure, I will activate this number 1 material as we assign the number 1 material to the substructure. So I'll use shortcut key, which is F4 key, and then measure this length. So it is 12.4 meters, and height of the column is 5 meters. And spacing of the column is showing 7 meters. Okay. I think we are done with this layout tab. And also we have advanced menu on the layout tab. So we input same value for the bearings at the abutment at the pier edge, but if you have different bearings for each abutment and pier, you can go to this advanced option and input the stiffness separately for each abutment and pier. And if you want to input spring to the column at the bottom here as a boundary condition, you can select spring support, then you can input certain amount of spring stiffness as well. Let's move on to section tab. I'll make a screenshot for this as well. Okay, so that thickness is 0.2 meters, and we have input 7 girders, and we have assigned number 2 material to deck and girder, and the diaphragm. Diaphragm means the cross beams, and we have checked on diaphragm to install the cross beams to certain area, which is end support and pier support, and also we have advanced option. And we have transverse stack element, which is representing the slab in the transverse direction, which is in order to distribute load to the girders more in a more realistic analysis. And we have selected a distance option and input 1 meters. Okay. So here we didn't have actually the slab section for the transverse direction. So we just created this additional section, which is to make the slab in the transverse direction. So the thickness is 0.2 meters. And we can measure distance between each transverse tag element, and it is 1 meters. And at the end, as you might remember, that overall length of this Girder is 60.2 meters. The last distance between the slab is 0.2 meters. So you can actually input. I have some description here. Just give me a second. So you can actually input 1 meter, or you can input 60 having 1 meter, comma 0.2 meter. Then the result will be the same. So you can input multiple distance here. Then you can control the distance between the transverse tag elements. And also we have some additional options for the diaphragm and the transverse tag element. So this can be distance and also divisions. So if you input 5 here, so the software will divide the span with 5 and install the crossbeam. Sorry, not the crossbeam, transverse tag element. And also it can be divisions per span option as well. And if you click off diaphragm, it will not install any crossbeam. If you click on diaphragm and if you go to advanced option, today I didn't input any crossbeam at the intermediate. I inputted crossbeams to end support and peer support. So here we have crossbeams at the peer and at the abutment, you can see here. If I input intermediate option, then the result must have been input some crossbeams here as well, somewhere here. We can control the number as well. And also we have different composite Girder section. As you might remember that we have 2 different Girder section, and if we want to assign the different Girder section along the longitudinal action, you can input the length of each Girder section. So from the start point to 2.5 meter, it will be number A section, and from 2.5 meter and to 27.5 meter, it will be number 6 section, and after that it will be number A section again. So number A section is from the start and to the 2.5, and after that it is number 6 section, and after that number A section again. And you can do this differently for each span. So we have span 1, span 2. If you go to span 2, and you can input different combination of the Girder section. So we are done with section tab now, and we will move on to tendon tab. Here you can see we have tendon profiles, which is curved. I'll explain this with the slide. So here's some input table. So the type of the tendon profile can be straight or curved, and you can assign certain tendon property and input the number of tendon and input transverse distance from this section reference line. And here is a transverse transverse dimension, and this is along the Z axis. Okay. So here's the table. So type can be straight or harpened or curved, and you can assign the tendon property and input the number of tendon. And after inputting the table, you can check with this small window, and here as well. And after you are done with this table, and if you install this to span number 1 and then click add, then you will see this number 1 line. And then you can input the table again. If it is same, you can leave it just as it is and go to section 2. If you click on add, then you will see this line number 2. Okay, and move on to load tab. So this is to generate the permanent static loadings automatically. So before we check on each load cases, we need to input the dimensions here. So B1 is here, the barrier, B5 as well, and B3 is median strip, and B2 and B4 are between the barrier and median strip. With having this dimension, when you click on median strip or bearing or additional load, it will calculate the load values. As we check on self-weight and wet concrete and barrier bearing surfaces, the model have load cases like this. Self-weight, wet concrete, barrier, bearing surfaces, and pre-stresses. And we have option, option here, equally to all Girder. I'll show you the meaning of this option. So if you check on this equally to all Girder, you calculate the total amount of the loading and divide by the number of the girders. And when it about the bearing and median strip, if you check on this option, and it will distribute the loading to all girder like this. Otherwise, it will input the loadings to only the certain area for to the relevant region for the bearing and median strip. Okay. And we can also input the live load here after selecting the code, and we can input traffic, the number of traffic lane with a certain distance from the reference line. Then it will create traffic line automatically as well. And the last tab is construction stage. If you check on this construction stage option, it will generate construction stages, otherwise it will not. So as I checked on this option, this model has stages. For instance, on the first stage, we have only substructures having only 12 beam elements, only the self-weight. If we go to stage number 2, we have only the girder without any slab, and having only the pre-stress load. And to the later stage, we have wet concrete loading. And later stage, we have deck element. And later stage, we have barrier and bearing space, surface loadings, and so on. Okay. So we are done with the widget. Move on to next. For the time-dependent material, because of the time, I would like to focus on more about the moving load analysis today. So I'll skip this. You can please follow all the steps with this presentation file we will upload this to our website within a week. I'll share the link and I'll send you the email to all the people who registered on today's webinar. Okay. So let's get started with moving load analysis. I'll show you how to define a moving load analysis. So for the moving load analysis, we can go to load menu and moving load. Select moving load here. We have various countries code here, and how to use moving load analysis is almost same, but different countries code has different load factors and different vehicle. That's why we separated countries code. So even you use Australia code or Europe code on your project, but you can study about moving node analysis with PS code as well. It is fine. After you understand about moving node analysis, then you can use other code as well. Okay, so today I will use PS code. There are 3 steps for moving node analysis. First is defining lanes and then vehicles, and using moving node case function, we make connection between the lane and vehicle. So we just did definition of traffic line lanes. So if it is plate elements, then we can go with surface lane function. But as it is all beam element, the wizard used the line lane option. So here you can see this is lane number 1, this is lane number 2, and this is lane number 3. So I'll define the vehicles. I'll use standard vehicles and HA loading, HA vehicle on the PD following PD 37 and 1. You can use a different code, or you can assign a different load factor, lane factors, and you can use a different factor for adjustment factor or reduction factor. But if you select the code, the software will follow the relevant code. Okay, I'll define HA loading and HA and HB auto vehicle. And this number of unit value, you can change it. The default is 30, but it may be increased up to 45 if so directed by the appropriate authority. Anyway, I'll use 45 to show you it can be modified by the user. And if you don't find any vehicle in our database, you can use our user-defined function as well, like this. You can manage all the values about the configuration of each vehicle. Okay, as we are done with the vehicle already, I'll move on to moving node case. So these lanes and the vehicles are showing blue colors. That means that we have the data of the lanes and vehicle, but we haven't not inputted, assigned this data to the model yet. So we need to make connection using this moving node cases. Simply add, and I'll name it as firstly HA. I will not use auto live load combination. This is for HA and HB vehicle, and add. I will apply this HA vehicle to 3 lanes, which are lane number 1 and 2 and 3, and okay. So the software we consider HA vehicles to lane number 1 to number 3. And I'll define another moving node case, which is for HA and HB vehicle. Sorry, I'll open again. HA and HB. I'll use this time auto live load combination and add this HA and HB auto vehicle. I'll apply this to 3 lane as well. This time I'll consider straddling effect. So if we drag lane number 1 to number 2 and assign this to this under HB straddling 2 lanes, then HB vehicle will be positioned between the lane number 1 and 2 as well. So it is considering straddling effect. I'll consider this for lane number 2 and 3 as well. Doing like this, and I'll click OK. And I'll tell you the differences with HA and HB with auto and without auto option. As you, sorry, I forgot to save this load case. As you might remember that within our standard, we have 2 HA and HB vehicle with auto, without auto. Let me tell you the differences. So if we use this automatic option, it will apply the relevant load factors according to the code to the axle loading value. So if you don't use automatic live load combination option, then it will apply the axle loading as it is. The original axle load value is 112.5 kilonewton. But if we use automatic option by selecting ultimate limit state and combination 1, it will apply the relevant load factor to the axle loading. To the UDR as well, actually. So this is the differences. So here are the load factors according to BS code. And you will consider straddling effect as well following the code. Okay. And actually we are done with, moving node analysis. How to define the moving node analysis is done. And I'll tell you about the additional option, which is optimization function. So we have 2 different optimization functions about the moving node. The first one is transverse lane optimization function. This is when you define just normal traffic line lane. So you can check on this option. If you check on this option, it will consider additional position of the vehicle in the transverse direction. So without that option, basically, originally the software MIDAS civil will apply the vehicle to the center line of the lane. But if you check on transverse lane optimization function, the center line is here, and you apply the vehicles to the edge of the lane here. This is left edge, this is right edge. So you will consider 2 additional positions in the transverse direction within 1 lane if you use this transverse lane optimization function. Okay, so that means as it considers more position of the vehicles, it might take more analysis time. You might notice that. And second option is moving load optimization function, so which is using this moving load optimization function rather than using just normal traffic line lane. So by using this option, previously we defined each lane. We had to define each lane manually. If we have 5 lanes, let's say, we need to input the lanes 5 times. But with using this optimization function, we can input the whole carriage width, whole transverse carriage width, and then assign the number of lanes. So here we can input the whole carriage width, and then each lane width, and here means how detailed we want to consider the moving load analysis, and wheel spacing and margin is the here. So if we input 2 meters here, it will consider every positions in the transverse direction every 2 meters. So if we input 1 meter here, it will consider every position 1 meter, so it will be more detailed analysis. That means also it takes more analysis time. Okay. And within load and moving load optimization, we can also consider straddling effect and to the crossbeam type as well. And in order to consider straddling a lane type, it must be a crossbeam type. Okay. And then we are done with moving load case, I guess. And we have automatic load combination. Here it says you can use automatic load combination following the PS 5400 code. We have Australian code as well, and RS2 and Europe code and so on. And you can check load factors for the vehicles as well. I'll skip this. You can please follow this, and if you find any difficulty, please visit our global technical support website. And I'll show you the result. Before we go to the analysis result, we have this option, which is very important. So I have actually performed the analysis with this modifier already. If before performing the analysis, if you go to analysis menu and moving load here we have lots of options. So regarding on moving load analysis, there's lots of things to calculate for the software. So we can simply skip a certain point. Let's say we don't need any stress result, we can check off, then it will not show you any stress result for the moving load cases. And if you need any only the maximum and minimum result, you can check on this. But if you need the relevant forces, concurrent forces, for example, you find the maximum bending moment, and under the same vehicle location, you need the relevant shear force, actual force as well, then you should select this option. And let's say you don't need to get any forces or moment under the moving load case at the substructure or at the crossbeam. You need only forces moment for Girder, then you can select group and select Girder group. Then it will not show you any result at the substructure or pier or transverse deck element. So you can save your analysis time. If you consider all, sometimes it takes a very long time for the analysis. When it comes, especially when you have lots of elements. I'll show you the result. You can check the reaction simply. I'll turn off the display of the elastic link. You can, if you check on the legend option, you can see on the right hand, you can see maximum or minimum reaction, and you can check the node number, which is showing the maximum or minimum result, and you can actually check on the value option as well. It will show you show you all the values following this unit at the bottom. And we can check deformation on the moving load cases. You can check this with load combination or other load cases as well. And we will check beam diagram, and we will check the bending moment. Here you can see maximum bending moment is showing at the 371 element. Sorry, 371 element. I'll activate only the Girder element. So maximum bending moment is showing at the element number 371. So if you want to see the location of the vehicle for this maximum bending moment at this element, we can go to moving tracer and bending moment and input here 371 and select bending moment and apply. And this is, I'll turn off the value. And this is representing the location of the vehicles. So red flags are showing axle loading, and blue color is showing the UDL. And here the curve, the diagram is showing the influence lines. So it is based on the influence line analysis. If you go to influence lines menu and input same element, then you will see without the vehicles, you will see only the influence lines. So the software about the moving load analysis, it performs influence line analysis first, and to the this influence line, you apply the axle loadings to relevant position to make the maximum or minimum result. That's how it works. And also, when you check the location of the vehicles for the maximum or minimum result, we also have this detailed result. So when we are not sure about the loaded length, and sometimes we need the data, then you can go to this detailed result menu and see the value of loaded length for each lanes. Okay. And some other factors as well. And you can go to tables. I'll check firstly about the number of the Girder element. You can, when you select certain elements, you can check the number here from here. You can copy this, and you can go to beam force table and paste here. Let's say we want to see moving load analysis at the I part at the element. Then you see all the maximum results at each element along the Girder. And let's say these are showing the maximum values. So it is maximum actual forces at this element, and it is maximum torsion force at this element. So each value is from a different location of the vehicle, and sometimes you need to obtain concurrent forces result. Then you can click right button, go to view by max value item. this is to see the concurrence result. You can check everything and click OK. Then you get all the concurrent forces for all elements. So here for this element, when the, let's say, shear force, it shows maximum, it shows torsion and moment and so on. So when it shows maximum bending moment, you can check under the same location, you can check shear force, axial force, and moment as well.